Hello, everybody, and welcome to the webinar. We today are going to talk with Tata Communications about how they achieved a truly interactive business operational intelligence application on a large multi-tenant Hadoop cluster. We have today Samak Mukherjee, who is the head of engineering at Tata Communications, and Ellie Singer, CEO of Jethro. So let's get started. Samak?
Yeah. Hello, everyone. Again, so I apologize for the little delay. It was my fault, just getting access connections. So let's get started. So just to, if you guys can see the screen uh, that was on my thing. So we'll go on the first. Let me describe what the business problem that we had encountered. So we are a global CDN, and Tata Communications, we are a global CDN, and we have services in every continent at this point. Now, as a result, we serve billions of CDN requests per day, and from a distributed system consists of hundreds of servers. So we have a distributed architecture where all our edge servers log every single request in real time, and that those requests are being brought into our centralized business analytics platform, business intelligence platform, where we can analyze the traffic and produce live reports for all our customers and also for internal use. While solving this problem, we started around a couple of years back, and we started investigating multiple commercial analytic platforms, but none of them could satisfy our performance and multi-tenancy requirements. One of our requirements of CDN is that every customer's data has to be segregated from every other customer so that they cannot be mixed, they cannot be seen. Only the CDN can see all the data and can view can create reports from there. So going on to the next slide, our data and applications. The next thing that we at the point we found is that when we are doing network analysis, traffic analysis, we have to continue to handle usage data like URL, duration of how long the user was on a certain site or watching a certain video, device type, geographical information like where the users are coming from. And we typically have hundreds of millions of users who are served through the system at any point of time, right? And we have also a lot of content publishers who are using our system, and they're uploading their contents onto the CDN, and then their end users are accessing the contents through the CDN globally. So this results in a really large data set, over 100 billion rows and around 10 terabytes of raw data that we maintain. And we add typically over a billion new unique events a day. We actually handle much more than that, but some of the events are not unique because they may be as a result of the same user clicking twice, and or something that it is coming from multiple servers. So, but it is over a billion new unique events are handled every day. We store this data for 90 days, then we roll them up into aggregates. Like for 90 days, we store every single data, which is to a few seconds. After that, we roll the data up into hourly, daily, and then monthly aggregates as days go by. All our customers who have access to the BI, who are CDN customers, they have access to our BI system through an app, and our BI system generates live reports, for unique reports as on demand from the customers, from the customers' users. One of our requirements was the SLA of around 30 minutes. So we pledge that any event that has happened will show up in a report that they query within 30 minutes of that happening. So that was a very important requirement for our BI system. So going to the next slide, were the approaches that we tried. So we have all our raw data that we gather. We have this distributed data gathering system which we publish the data from, and that is stored in our Hadoop and large Hadoop cluster, right? And the ETL process, then we have an ETL process which converts it into analytic data. We had initially, when we started the Hadoop cluster, we used Impala and Hive for live reporting, but we ran into problems with that. And the primary problems was the issue of partitioning. Since we have to segregate all the data, right, and since every customer has their own basically data cube, right, and we also need to partition data by day so that we can purge as after 90 days go by, we can purge it in a rolling window, right. The amount of partitions created became really unmanageable. It was huge. Over 3 million partitions were created by the multiplication of product of the number of customers times what we are having. So that caused new data ingestion to got very slow, right? And which resulted that we could not either query both new data ingestion or query the data within the 30-minute time period that we have set for ourselves as SLA, and resulting it obviously in poor BI performance. So going back, going to the next slide. So then, as part of our research, we came across Jethro. We came across the Jethro team, and we started trying Jethro for a couple of months, and then we found that Jethro did solve the problems that we wanted. In fact, since it allows us to index columns, right? The partitioning problem was mitigated, right? And it's also just to allow us for incremental ingestion, so that we are not doing it in batches, and which also allows us to maintain performance, hence allows us to do the 30-minute maintain a 30-minute SLA. And the query day, when a report is being queried, it does not affect if new data is being ingested, so they go on in parallel. So right now we have implemented Jethro across our system. So all our report BI access is through the Jethro platform, under which overlays the Hadoop layer. And now we can create interactive custom reports across multiple dimensions. All these things are customer dependent. So customers, we have all the dimensions that we gather and we store. Customers can query and create their custom reports based on what they want to see. And we typically process multiple billions of records a day at this point, right? The other thing I do want to mention is Jethro has worked with us very closely, almost as a partner, and we are I cannot be any happier about the level of technical support that we received from Eli and his team and the whole Jethro team. Whether when we have new features coming out, when we had issues trying to debug that, and working through different time zones. We are based out of California in San Francisco Bay Area, and Jethro is in New York. Plus, their engineering team is in Israel. So we had no issues whatsoever working with them, and in fact, I cannot be more thankful for that. Going forward, our current environment, we have what we call a medium-sized Hadoop. We have many tens of servers, Hadoop servers, right? Mostly they are used for ETL, storage and ETL, nothing more. We have, on top of the Hadoop layer, we have the Jethro overlay, where we have multiple Jethro servers. Some of them are dedicated for ingestion only, and the rest are dedicated for queries. There are more query servers than ingestion servers. As I said, our average events is more than 1 billion. The raw events are more than 2 billion that we get, and the unique what we process, which is also processed by Jethro, goes over 1 billion. We ingest new data every 15 minutes, right, in the system. We record the data as it is happening, whenever it's happening, every time, but we ingest them every 15 minutes, and allows us to maintain our sub 30-minute SLA for report query. Data is partitioned by day, so that we can purge data as when 90-day or whenever the policy allows, we can purge the day-by-day data. We don't have to do in batches of months. That's a huge advantage, because a lot of customers, they want rolling reports of the last 30 days, last 90 days, last 120 days to see how their traffic patterns are looking. And we are creating new and more reporting apps on top of Jethro, or we have built our own app server, and we built on which talks to the Jethro system, and we are creating new reporting apps to allow the customers to access those apps easily. reports easily. I mean. One of the biggest impact. This is the system is now live. Our system. This is it is used globally. It is used for across. It is used in across the continents. So we have customers obviously across the world, in US, Europe, APAC, and India, or four major regions, and Australia, and customers all over the place. They are using the system concurrently, and they are use that to make their business decisions dynamically. For example, one of our biggest usages is companies look at their how they send ads, insert ads into their content for videos based on who is watching, how long is their viewing time, what type of ads are being looked at. We capture all those information. Are they skipping skipping that, and all those things help customers to have more targeted messages, whether ads, whether for content being distributed. Also, it helps them in content acquisition. Every country can have different acquisition rules and acquisition content. So this does help in for the customers to decide which content is popular in which region, and accordingly spend money in the acquisition costs. As a result of this, obviously, a lot of those reports which were not possible before because it was delayed and it had no value. If a report is delayed by 24 hours, some of those reports have no value. Now it can be done through Jethro within by 30 minutes, and that gives that is a huge help for our customers. And I have spoken to customers who have said that they use this regularly to make business decisions in terms of because it is timely. And since it is less than 30 minutes, that's pretty fresh data in terms of, in fact, it is faster than sometimes customers can even consume them. And as a result, we have also created automated scripts and automated systems where they have these reports being generated through Jethro and being pushed into a storage location where the customers can pick it up from so that they can do trend analysis for their data. Onboarding customers is completely transparent. So when a customer is onboarded for this system, they don't know it. As soon as they sign up, we have automated systems which uses the Jethro platform so that we can onboard the customers into their own partitions, in their own indices to do that. And that definitely helps. That definitely helps in the operational aspects of running the CDN. We also have reduced quite a bit in terms of just operations. We have reduced quite a bit of the operational costs of the CDN in terms of how do we do data management, how do we do cluster management, and that obviously is a big help in terms of cost control for the CDN. And Jethro is using Jethro has helped that quite a bit. So again, with that is our overview. I will let Ellie take over from this point, and after that, any questions anyone have, I'm happy to answer.
Thank you, Samik, for the great presentation. It's been a great experience working with you, Richard, and the rest of the Tata Communications team. It's been a very challenging, interesting, and hopefully successful project. I want to take the next few minutes talking a little bit about what Jethro does and how we operate and how our technology works. At a very high level, we're trying to solve the problem of making interactive BI work on Hadoop. If you think of Hadoop, the architecture is really optimized for data science-like workloads, where the queries are very wide, they access most of the data, so full scan really works well. There are a handful of concurrent users, data scientists, and they mainly run batch jobs. Interactive BI is very different. It's about many concurrent users expecting live interactive response time in seconds, and typically running very selective queries. BI users drill down and look for small subset of the data. When you try to run interactive BI on Hadoop, you typically realize the Hadoop trade-off of size and lower cost obviously conflicts with performance. So what can you do to make interactive BI work on Hadoop? There is a range of things people have been trying. One is repartitioning the data. Try to create partitions or replicate the data and use different partitions to minimize the impact of full scan. This, of course, works for queries that can use the partition key for filtering. Any other query would still have to go and do a full scan. Another approach is denormalizing the data. Since doing joins in Hadoop is very expensive, by denormalizing the data, we can avoid some of those performance costs. At the same time, we're now creating a maintenance nightmare. We have to rebuild the entire table every time we want to update some of the more historical data. And another approach is creating summary tables or cubes, essentially knowing which reports, which applications would be running in an environment, and pre-aggregating the data according to those reports. Of course, this scenario and this approach is very limited because when we have agile environment, new applications being created, keeping up with those aggregations and cubes is futile. So as a result, all of these efforts are expensive, labor-intensive, and ultimately ineffective. The approach we took with Jetro is different. We built the Jetro BI engine, which is really automating indexing and cubing server for BI on big data. The way it works is that we have the BI tool on top, and every time the user interacts with the BI application, the queries are being sent live to Jetro. When Jetro receives those queries, we use a combination of features to speed them up. We use indexing. We actually index every single column of the table. We use query result reuse. So if we see a specific query and the same query repeats itself, as is the case with dashboards, we only get to do the work once and then reuse the results. And lastly, Jetro would automatically, in the background, build microcubes, essentially aggregations that can serve a repeatable query pattern. Everything that Jetro has, all the data, the indexes, the column files, the cubes, the cache, everything is stored in Hadoop, and only in Hadoop. It never leaves Hadoop. And everything can be incrementally updated automatically by Jetro. Very limited maintenance effort. We put together a live demo to show how Jetro would work in a real environment. We took a TPCDS dataset that had about 1 terabyte of data. The fact table has about 3 billion rows and about 7 dimensions. And then we put it on a cloud. We essentially have both Tableau and Qlik as BI applications, and there are servers running on Amazon. They both connect to a Jetro server running on Amazon, which then connects to the data that is also stored in Amazon, either in EFS or HDFS on Amazon. These are publicly available. You can go to tableau.jetrodata.com, and the login is user demo. The password is also demo. I encourage you to go there and try it yourself. Torture the system as much as you can. And as we log into the application, what we will see is a typical Tableau dashboard. It has multiple charts, 5 or 6 charts here. Every time I would interact with this application, every change I will make will result in about 12 queries being sent live to Jetro for processing. As we can see on the top left, there's about 3 billion rows right now being accessed in this chart. And I'll start doing what users do, drill down. So let's focus on a specific year. And then maybe choose a handful of states I care about. And a handful of product categories. Then just zoom on these product categories. I'm just randomly doing selections here. And you can see that at this point, we're already down to 3 million rows out of the 3 billion rows. So essentially, after my filtering, we're accessing 0.1% of the overall data. Now, when you look for a very small subset of the data out of a very large data set, having indexes that point you exactly to where that data is very efficient compared to having to full scan the entire data set to find the rows that you need every time. So that is the power of Jetro. Let me go back to the presentation. Here is what the range of queries that Jetro typically sees from BI and how we handle them. The first type of queries we see are very filtered ones, just like I showed in the demo. When we already have multiple filters and the subset of the data is very small, Jetro would use those filters to narrow down the result set and only go and access the rows it needs for that query. So indexing works great for very filtered queries. Then we have the exact opposite. When I just start the dashboard, let me go back to the demo. and click revert, which means just go back to the top, no filters applied. This is also instantaneous. The reason why is because we already been to this screen once. And since those queries already ran, the results are cached in Jethro, and every time somebody goes back to this screen, we automatically reuse the result set. So those queries don't really benefit from index, there are no filters here, but we only do the work once. And because there are no filters, they're very generic, so they repeat themselves very often, and that's how we benefit from that. The third is really in between, queries that do have some filtering, but not a lot. They have some repeatability, and again, not a lot. And Jethro here uses our automatic aggregation, our AutoCube generation feature. And every time we find queries like that, and we see some patterns that repeat themselves, Jethro would automatically create those aggregations. And if I go back to the demo, you can see that no matter how I select states from that map, there is always going to be very fast performance because we already built the aggregations for this kind of query. So within those three features, Jethro can speed up every single query a BI tool can generate. And that is ultimately the promise of Jethro. Consistently performance queries for any BI use case. Whenever you have a BI tool running on a large data set in your big data platform, be it Hadoop or a cloud, Jethro will provide you performance that is as good as that you're used to from your EDW or even better. The second reason to use Jethro is that you eliminate all this extra work for data engineering. You don't have to build those partitions and denormalizations and aggregations and cube and manually manage them every time data changes. Jethro eliminates that need completely. We can scale Jethro to thousands of users. The maintenance is fully automated. When new data is being added, the indexes get updated and the cubes get updated. The cache gets updated. Everything is done automatically by Jethro. It applies to a full range of BI applications. It works with most of BI tools and most of, well, pretty much every Hadoop distribution as well. And it's easy to get started. We provide free POCs and pay-as-you-go licensing. So thank you for joining us for this webinar. We really appreciate your interest. Look forward to connecting with you directly. Thanks and have a great afternoon.